So now that we have done our lab, we're going to switch gears and do a little gas stoichiometry. I know stoichiometry is your favorite thing. Before we can do that, though, we have one last task to do with our mole map. We need to update our mole map. You may remember yesterday we talked about the fact that at standard temperature, chemists have said that standard temperature is 273 Kelvin. At standard pressure, the atmosphere pressure is 1 atmosphere in that unit. If you have 1 mole at STP, it is going to have a volume of 22.4 liters. So if you get your mole map out, and up in the upper left-hand corner, write volume of a gas. And the substitute can pause here for you all to get your things out and get caught up. Now, if 1 mole is 22.4 liters, 2 moles would be 44.8 liters. So the way to convert from moles to volume is to multiply by the molar mass of a gas. And that would be multiply by 22.4 liters per mole. Now, this is only at STP. If it's not at STP, it doesn't work this way. By the same token, we would divide by 22.4 liters if we're given a volume and we want to change to moles. And again, STP. All right. So we're going to use this today and do some stoichiometry. A reminder, when we do stoichiometry, we take the known moles and we multiply by the mole ratio, which is the unknown over the known. Okay? Our first problem wants to know volume of nitrogen. Okay? Before we can figure that out, we got to figure out how many moles of nitrogen we have. We know that we have 1/10 of a mole of hydrogen gas. So 0.100 moles of hydrogen gas. We know moles. Multiply by the ratio, 3 moles of hydrogen gas to each 1 mole of nitrogen is going to give us 0.0333 moles of nitrogen. Now, we can use PV equals nRT as our ideal gas law to calculate volume, but we can also do the shortcut that I just showed you with your mole map. Because it's at STP, we can multiply moles, 22.4 moles of nitrogen, and figure out how many, well, we can take 0.0333 moles of nitrogen and figure out how many liters that would be by multiplying that by 22.4. And if I do the math, and you would think I would write this down. I've done it enough times today, but of course I haven't. We get 0.739 liters. Now, I could have done that wrong because I'm doing it on the computer and I'm in a hurry. So check my work. And if you guys disagree, have a conversation about it. The substitute will stop the video. The next one, we don't have at STP. So we're going to have to do this a little. We'll just start the same though. We still have 1/10 of a mole of hydrogen gas, and we're still going from hydrogen gas to nitrogen, so it's still a 3-to-1 ratio. So we still get 0.0333 moles of nitrogen. But now we're going to use PV equals nRT. The pressure given is 0.941 atmospheres. Volume is what we're solving for. The number of moles is 0.0333 moles. I'm going to have to move this over. Again, you would think I would know what I need because I've done this twice today already. 0.0821 is our gas constant. And the temperature is in Celsius, so we need to change 215 Celsius to Kelvin, which comes out to be 488. And when I did the math on that, I found 0.371 liters. Again, check me. Make sure I did it right. Number 3. We have 0.100 grams of hydrogen. So first we have to change it to moles, 2.016, because there are 2 atoms of hydrogen in each molecule. And then once we get to moles, we go ahead and change it to moles of nitrogen. And we get 0.0496 moles of nitrogen. Okay? Since we're at STP, we can just multiply by 22.4 liters off of our mole map, and we get, oh dear. I hope you all discussed the fact that 0.371 was wrong, because that's the answer to this one. I don't remember what the answer. I'll have to do the calculations. The answer for this one, hopefully you already discussed, is 1.42 liters. All right. Number 4. We're going to start with 75.3 grams of ammonia. So first we have to change that to moles. The molar mass of ammonia is 17 grams in 1 mole. There are 2 moles of ammonia for every 1 mole of nitrogen. And when we do that math, it comes out to be 2.21 moles of nitrogen. Can I use 22.4? No, because we're not at STP. So again, we're going to use PV equals nRT. Our pressure is 4.56. Volume is what we're solving for. N is 2.21 moles of nitrogen. R is 0.0821. That's our gas constant. And finally, if we add 215 to 273, we come up with 488 Kelvin, just like before. Divide both sides by 4.56. $19.4 liters. All right, we're going to stop there. We'll go over it more next week. Next up, substitute's going to pass out the worksheet, the gas laws. Okay, this is set up so that if you are into defining the different variables, there's a spot for that. And this covers Boyle's law, Charles' law, Gay-Lussac, combined gas law, and ideal gas law, Pevner. So, what I want you to do is let's go through and write down what gas law you'll be using for each one of these. The first one is Gay-Lussac. Pressure 1 over temperature 1 equals pressure 2 over temperature 2. The second one is asking for mass, If we want to find mass, we're going to have to find moles. If we are looking for moles and we have liters, temperature, and atmospheres, we're going to have to use the ideal gas law. Pervnert. Once you get an answer in moles, then you can multiply by the molar mass, which is 44 grams per mole, and come up with grams of carbon dioxide. And there is a key of this, and I think I've already loaded it onto Moodle. If I haven't, I will. Step 3, we've got liters and pressure and temperature, and then we're going to solve for a different volume, different number of liters. We still have temperature and pressure, so this is the combined gas law. Step 4, temperature and volume, so this is Charles' law. And again, pause it as you need. Step 5, pressure and volume, so this is Boyle's law. Step 6, pressure and volume and temperature. Question 6, I don't know where step came from. Notice it says STP. What did we decide STP was? Standard temperature is 273, standard pressure is 1 atmosphere. Okay, so this is combined gas law. 7, pressure and volume again, Boyle's. And 18 gives us grams of water. We can change that to moles and then use the ideal gas law to calculate the volume. All right, so do this for Friday. There's also some questions on there. You can answer those. You don't need me. You will have a quiz on Friday over this. And then after the quiz, the substitute will pass out the reviews for test 5, which will be next week on Wednesday and Thursday. That would be, oh my heavens, May 1st and 2nd. All right, so you guys can start working on that. You will have all day Monday to work on that. And on Tuesday, when I'm back, we'll have time to work on it as well. Thank you.